Hello everyone. Before going into migration tools, let's first talk about migration strategies. I'll touch base upon a few terminologies which are very important and very much prevalent in the migration world. The agenda is very simple. We'll talk about migration terminologies and phases. Migration is one of the most complex work which you might come across in your career as an AWS architect or as a cloud architect for that matter. To provide proper solution, we need to know how to go ahead with migration and what things to consider. But before going into migration, I want to set stage right. Let's have a discussion on few architectural terminologies. First, what are Greenfield and Brownfield projects? You might come across these terms a lot. Greenfield project involves a work which is not following a prior work. That means in a Greenfield project, we need to start everything from the beginning. In IT term, which means creating a brand new application or a brand new feature in an application. I'll take example of our typical 3-tier architecture again. Here's our 3 tiers. Front end or web tier is in AngularJS, application tier or backend is in Node.js, and database is being hosted on MySQL. Everything would be new in this case. We'll have to write the codes in AngularJS and Node.js from the scratch and create brand new databases, complete testing, and deploy this entire application in production. Then we have Brownfield project, which involves a work wherein you have to demolish the existing structure and create a new one. It means that we need to re-architect and restructure our existing application. This is one of the toughest job to do. We have the same 3-tier architecture again, or 3-tier application if you will, but in this case, we already have an existing application running. The front end is using basic JavaScript, backend is using Java, and database is running on Oracle. But we've got a requirement which says that we have to change our application. We'll have to move from JavaScript to say React.js and change backend from Java to say Python for some reason. In that case, the project would be called as Brownfield project, where we have to recode, re-architect, and re-solution the entire application. Let's talk about a few more terminologies. The R's. These R's are very important vis-a-vis cloud migrations. First is rehosting. Rehosting is also known as lift and shift. If you take a look at the word, it has hosting in it. That means no changes in the application, but the place where the application is hosted would be changed. For example, moving a Java application from on-premise server to EC2 instances. In this case, the application is same, but before migration, it was hosted on on-premise server, but after migration, it will be hosted on EC2 virtual machines. This is our on-premise server, and we are hosting a Java application on it. We want to move this application as is to AWS cloud or to EC2 instances. Nothing in the application would be changed at all. While moving, it has to be recompiled, redeployed to EC2 instance though. So this application would be moved to EC2 instances without changing any of its architecture or feature. This is called lift and shift or rehosting. The next R is replatform. Here, the platform is being changed. In cloud, we have platform as a service, if you remember. So moving on-premise applications to platform as a service on AWS cloud. Replatform actually means moving applications to managed services or PaaS. In AWS, you have RDS, Elastic Beanstalk, which are platform as a service offerings by AWS. So we move existing on-premise databases to either RDS or applications to Elastic Beanstalk. Managed service is something which is managed and maintained by the cloud vendor. In our case, it's AWS. Think about RDS. We do not have to do anything in RDS, right? Everything is taken care of by AWS. Similar is the case with Elastic Beanstalk also. We write the code and upload it to Elastic Beanstalk application, and AWS takes care of the rest. These are AWS's PaaS offerings. This is our on-premise server, and we have a MySQL installed on it. Applications store and retrieve data from this MySQL database. As we decide to move to cloud, we have to make decision where to rehost MySQL or replatform. Don't get surprised, we can do a rehosting of databases also. In that case, rehosting is nothing but changing the hosted infrastructure only. If we want, we can install MySQL on EC2 instance and use it just like the way we are using it from on-premise servers. But replatform is changing the platform itself. If we decide to use MySQL on RDS instead of installing MySQL on EC2 instances, we are essentially doing a replatform. Moving this database to RDS would be replatforming our database. We might choose to use MySQL on RDS itself. We can use something else also. So this is PaaS. We could have done the same thing with our application also. Had we moved our Java application to Elastic Beanstalk, we would have replatformed our application as well. Remember though, in replatforming, we need to change our application code. For example, if we move our database to RDS, database endpoint would change. So all applications which were using MySQL on-premise would have to be pointed to RDS application or RDS endpoint. The third R is repurchase. This is the most straightforward. It says purchase a new thing. In our case, the thing would be software. So repurchase is to migrate your application to SaaS, keeping the same or different product. While repurchasing, we can change the product itself or keep the same product, but move to SaaS or software as a service. As discussed in the introduction, in SaaS, we use the end product. Everything else is managed by the service provider. AWS does not have any SaaS offering, but other vendors provide SaaS on AWS itself. We can find those in AWS Marketplace. Let's take a small tour of AWS Marketplace. Type aws.amazon.com/marketplace. It will take you to the AWS Marketplace. So this is the AWS Marketplace. If you see here, it has AMI and SaaS. That means you can get AMIs also or software as a service offering also. Let's see WordPress. WordPress is very famous. So if we want, we have WordPress, which is certified by Bitnami. If we use this or if we launch this WordPress and use this WordPress in our application or in our basically the entire business, then we'd be using software as a service. We can use MongoDB Atlas as software as a service also. So if you see, MongoDB provides MongoDB Atlas for AWS, which is the SaaS offering of MongoDB. We have SaaS for SAP HANA also with 244 gigs. Some are AMIs, some are SaaS, as I said. In some cases, you'll get AMIs, you'll have to use that AMI to launch your EC2 instance. But in some cases, you'll just click this and that service would be launched. You'll have to use the endpoint of that service in your application. So AWS Marketplace would typically provide you software as a service offering if you choose to repurchase. While repurchasing, we can choose to go for a different product or software altogether. Refactoring or re-architecting is not so tightly coupled with cloud. It basically means that we want to change the architecture of the entire application. A simple example would be to change from monolithic application to service-oriented architecture or to microservices. It can be done with or without cloud technologies as well. These are the final two R's, retire and retain. Retire means then the entire application or a part of it would be done away with or removed as the need for us to have this application component is not there anymore. Retain is just the opposite, which means keeping the application on-premise. It will not be migrated to cloud at all. Let's see all the R's together using our typical 3-tier architecture. This is our end-to-end application. This is the simplest example I could give. Our plan is to migrate this entire application to AWS. Which R to use where? That's a decision which you have to take as a solutions architect. Of course, you'll have to take help of application developers, database administrators, business analysts, application admins, etc. But yes, the end decision would be upon you. A lot of factors would come into picture like cost savings, ease of maintenance and management, ease of migration, etc. It's not necessary that we'll have to use same R for all of them. For example, I can choose to rehost this component on EC2 instance, or I can choose to rehost my front end to cloud. I can choose to refactor or repurchase our backend application using SaaS or Elastic Beanstalk and replatform this component using RDS. Decision depends on multiple factors as I mentioned earlier. Having discussed about multiple terminologies, let's see what phases are followed in a typical cloud migration. First three phases are evaluate, plan and discover. In evaluation, we check for business objectives and goals of migration. Why actually the migration is needed and what is the main purpose of migration? Is it to save cost or for operational efficiency or something else? Do you have to follow some sort of security and compliance requirements, etc.? Then the harder parts are plan and discover. We plan based on multiple factors like business criticality. For example, high priority applications should be migrated first. What is the impact of a particular application? What is the application size and frequency of use? Those things factor in to get us the criticality of a particular business. Then we have application complexities. Least complex applications should be migrated first. Complexity is decided by checking application technology stack, application architecture, dependencies between application, and underlying infrastructure, etc. Then we have priority of environment, like dev environment should be migrated before QA and prod, etc. Then finally, we have application discovery. Application discovery is a way to find out how all components of an application are related to each other. What dependencies do they have with one another, etc. Let's discuss this using an example of our 3-tier architecture, but this time the diagram would be a little complex. This is our 3-tier architecture. UI has 3 subcomponents. Each one of them might be written in different programming languages. So this one might be in React.js, this one might be in AngularJS, or this one might be in simple JavaScript. Same is the case with application tier. All of them might be written in same or different programming languages. Suppose this one is in Python, this is in Java, and this is in Node.js. And you are using 2 different databases. Say this is Oracle, this is MongoDB, or this is Oracle, this is DB2, etc. Suppose this is how all components are related and dependent on each other. UI is talking to these 2 applications. This UI is talking to these 2 application components. This UI is talking to this application component. Now all these application components are talking to the database like this. So if you see, the bigger your application, more complex your entire dependency and linking becomes. This is very important before we start migration. We have to see what are the dependencies and how each application components are linked with one another. Because if any one of the link is broken after migration, then the entire application will fail. This is where application discovery comes into picture. Don't worry, there are tools to find all these dependencies. AWS provides something called application discovery service, which can be used to find exactly all these links and interdependencies. There are third-party tools also like ADDM, BMC provides a tool. We have something called Etadata, etc. Once we have all this information, then we decide which application to rehost, to replatform, repurchase, refactor, retain, or remove. These re-stuffs pertain to migration projects only and not for Greenfield projects on AWS. After we finalize our migration strategy and plan, we need to create something called landing zone on AWS. Landing zone is the place where all our applications will be placed in AWS. For this, we typically need to decide upon and create 5 components in AWS. First is AWS account, then networking. We'll have to design our VPC components, like how many VPCs should be there, what would be the number of subnets, which subnets would be public and which subnets would be private, different firewall rules using security groups and network ACLs. Of course, we can modify these things later on also. Then identity management, which provides access to AWS resources using IAM or on-premise identity provider like Microsoft AD, etc. Centralized logs design using CloudWatch logs. Then deployment pipeline using CI/CD tools. This is a developer's job though. AWS also provides CI/CD tools like code commit, code pipeline, code deploy, code start, etc. We can use third-party tools also like Jenkins, GitHub, JUnit, Maven, etc. We also have multiple tools provided by AWS. These are the ones. AWS Application Discovery Service, which is used to find application dependencies and interconnectivities between applications. Database Migration Service, which is used to migrate databases from on-premise data centers to AWS RDS. We'll discuss AWS Import Export, Server Migration Service, and AWS Snowball. Schema Conversion Tool is used to perform homogeneous and heterogeneous database schema migrations. AWS Migration Hub can be used to track migration tasks across multiple AWS tools. There are enormous number of third-party tools also, which can be used for migration purposes. One of them is Cloud Endure, which is very famous, and AWS also suggests to use Cloud Endure if you are not using AWS services. That's all I wanted to talk about migration. I hope I have not overwhelmed or scared you, but trust me, if you are involved in at least one AWS migration project, I think that would be the most interesting and challenging work you do in your IT technical career. Thank you.